So this is a series of lecture. Good morning, and we are today. This is a series of lecture on special theory of relativity. So before starting the special theory of relativity, we will discuss something about what is relativity. Okay. So the idea of relativity, when everything which moves has certain reference frame relative to which it is moving. When we say that a car is moving, say by 100 km per hour, we assume the earth to be at the reference frame, and we assume that the car is moving relative to the earth. Now we have already assumed, but we haven't. We simply say that the car is moving, but behind the mind we assume that it is relative to the earth. So every movement you will see that it has certain reference frame relative to which it is moving. According to Galilean or Newtonian theory, according to Newton, there is something which is called absolute space. Since everything is moving relative to the car is moving relative to earth, the earth is moving relative to the sun, and the sun is moving relative to the galaxy. So everything is moving relative to one another. But according to Newton, there is something which is called absolute, and everything is moving that relative to that absolute space. But these ideas are now obsolete because there is no something which is called absolute rest or absolute frame. We will discuss these things later on. Then when the light, when the people measured the speed of light, they found that the light moves with has certain velocity relative to which has certain value. So it means the light has certain velocity. It's a moving thing. Then by 19th century, end of the 19th century, or in middle of 19th century, when it was supposed that according to Maxwell, the light is an electromagnetic waves whose speed is equal to which was speed of light in vacuum, which was calculated to be 1 by under root mu times epsilon times, which works out to be 3 into 10 to the power 8 meter per second, or say 3 lakh kilometer. So according to Maxwell, light is an electromagnetic waves which moves with certain velocity, and the velocity is this much. This is the approximate velocity, and it's not the accurate, it's 2.997 and so on. So it means light is something which is moving. But what is light? Is it a particle which is moving? No. Earlier the people assumed, according to Newton himself assumed light to be a particle which is moving with certain velocity, and he assumed the light particle to be a corpuscle, but that theory is not existence, because then by the time of the 19th century, people has agreed that light is not a particle, but it is a wave. But then after 1905, photoelectric effect, then the particle phenomena again appeared, but I am not going to discuss those things. But to assume that light is a wave, an electromagnetic wave according to Maxwell, which has certain speed. Now if the light is a wave, suppose light, we have taken granted that light is a wave. If light is a wave, there must be certain medium relative to which the light propagates. When we throw a stone in the water, the base in the water forms, and the medium in that case is the water is the medium through which the wave propagates. My sound, my voice is reaching your ear by the movement of the wave produced in the air, and that the vibration of the air medium hits the eardrum, and the difference of pressure, the frequency difference of the pressure at your eardrum reaches there. So the sound wave is propagated through a medium here. The medium here is air. So for every waves, there must be some medium. If we assume light to be a wave, there must be certain medium through which the light propagates. That air cannot be the medium for the propagation of light, because air is beyond 100 kilometers above there is no air, but the light is coming from the sun also, which is several 15 crore kilometers away from us. But there is no light, there is no air in between. There is vacuum, completely vacuum, but still light is coming to us. Light is coming to us from stars, which are billion of light years, several light years away from us. Still light is coming, but there is no air. That it means the air cannot be the medium for the propagation of light. And also light passes through the glasses, through the water, through the air. It means that medium through which light propagates must be there in the glass also, must there be in the water also, must there be inside all the bodies also, because X-ray passes through our body, can pass through our body. It means that medium must be inside our body also. So the people assume a hypothetical medium. Hypothetical medium, and called it ether. And suppose that light propagates through a hypothetical medium called ether. Now, if there is ether through which light propagates, it means ether must everywhere. Inside the body, outside the body, within the body, without the body, everywhere. Because light propagates inside the body also. And X-rays, gamma rays pass through our body also, it can pass through the walls also. Visible light can pass through air, glasses. So it means ether must all pervading. It must be everywhere. Now, if ether is everywhere, there must be certain resistance to the movement of, because if this is the earth, and suppose the whole thing is everywhere, it's ether, the star is here and sun is here, light is coming from sun to the earth through the medium ether, but the earth is rotating. Since the earth is rotating relative to the ether, it means ether must offer some resistance to the movement, and the time period of the earth must have changed. But it has been found that there is no change in the time period of the earth due to this relative motion of earth relative to the ether. So people assume that ether is all pervading. It is completely elastic medium. It offers no friction. It offers no change in the kinetic energy and so on. So it's completely all these properties given to the ether in order to explain this phenomena of propagation of light through the ether. Because you have assumed it's a hypothetical medium, you can give all the properties whatever you like with that capacity medium just to satisfy your idea that the light has to propagate in some medium and that medium is ether. But two American scientists, physicists Michelson and Morley, tried to measure this ether, and the idea was very simple. The idea to measure this hypothetical medium by Michelson and Morley was simple like this, that they assume that if the earth is rotating related to the ether, because it means everywhere it's ether, and the earth is rotating by certain velocity d. So they think the earth and the ether to be like a river which is flowing. So if you assume that this is the river, and river has certain velocity, say u, and this is the boat which has a velocity v, and this is the observer here. This is the observer. O is the observer. According to the observer, if the boat is moving downstream, its velocity relative to the observer will be v plus u, because v is the velocity of the boat relative to the water and u is the velocity of the water in the river relative to the earth. So the velocity of the boat relative to the observer will be v plus u, downstream velocity, and the upstream velocity, this is downstream velocity. Of course, the upstream velocity will be v minus u, because the boat is moving against the current, water current. Its velocity will be v minus, because it's upstream. Upstream velocity. So if you take the time taken for the boat to travel up to a fixed length, say from A to say B distance, the time taken by the boat to travel downstream will be lesser than the time taken by the boat to travel upstream. Okay. Now if we take the boat to travel across in this direction, the boat is moving with v velocity and the stream is moving with u velocity, its velocity will be in this way, and velocity will be v square plus u square under root. So the boat will move from, say, this point A dash to B dash in this with this velocity v square plus u square, and then the return, it again has a velocity u, stream velocity, v its velocity across the river, and it moves in this direction. It's again v square plus u square. So the time taken will be same, from going to A dash to B dash to B dash to C dash. And from A dash B dash is moving with same velocity v square plus u square under root. It's coming with again v square plus u square under root. But in the upstream and downstream time will be different. So this idea was taken by the Michelson Morley to explain about the ether. So the idea was that if you assume Earth, this is Earth, and this is ether. Assume ether to be a river current. It's moving, the ether is moving relative to the earth. And assume the light pulse to be a boat. If the light pulse is moving from, say, with this velocity c, and the ether wind is moving in this direction, because the earth is moving in this direction, so the ether wind is moving relative to the earth in this direction. So if we take the light, the speed of the light related to the earth will be c plus b, and we place a mirror here. So the light which moves downstream, it will be c plus v, and in the upstream it will be c minus v. C is the speed of light, that's the speed of boat, and this is the speed of stream. So it's c minus v and c minus v. C plus v and c minus v. The time taken by the light to travel from this point, from the source to the mirror, and from return from mirror to back will be different. If we could measure this difference in time, we could measure the speed of the ether. Okay. So this idea was taken by the Michelson model, and if you take put a mirror here, perpendicular direction, the light travels in this direction, and this direction will be c square minus v square, because this is the source of light, and this is the velocity of the ether, and the light is moving with c speed. So that the speed of light perpendicular will be c square minus v square under root. So the time taken by the light to travel in this direction will be c square minus v square under root, and return will be the same, c square plus v square under root. So in the perpendicular direction, the time will be same, but along the stream and upstream and downstream, the time will be different. So this idea was taken by the Michelson model experiment to explain whether ether exists or not. So Michelson Morley So what Michelson does is that it has taken a mirror here, half silvered mirror at 45 degree to the direction of the incident beam. So if you take a source of light here, this is the source of light, take a single ray, this is the source of light, S is the source of light, and we are considering only single ray because the whole thing is enclosed in a box, and there is a pinhole so that only one ray passes through it, and you place a glass mirror here, incline at 45 degree to the direction of propagation of light. This is the direction of ray of light, and this makes it 45 degree. So this is about half silver mirror. It's half silver because half of the light crosses through this, transmits, and half the light is reflected. So if this is half silver, then half of the light will be transmitted through it, and half is reflected. Because it's 45 degree, the normal is here, so the reflected light is in this way. Now, since this light has to pass through this glass plate, and this is reflected light has not to pass through the glass plate, we put a glass plate here parallel to this mirror, same thickness and same material, so that the length through which the light passes through the glass remains same. If the light passes through the glass plate here, it also passes through the same material here. So the light which travels through the glass plate, path length will be the same. Now put a mirror here, say M1, and put a mirror here. So this is simply a glass plate, so light just simply passes through it. This is glass plate. Just to compensate the path length, make path length equal. So the glass light passes through this. After reflecting from M2, returns back. From there also, here also from M2 it retraces path. And this ray passes through the half cylinder. Half of it will be reflected, half will be transmitted. And this light which is coming from M2, which passes through, this also passes through this. And so you put your telescope to see the light. Now in the telescope you find that you are receiving two light sources, one from M1 and one from M2. And you are as you got light from two sources, say it's M1 and M2, and you see this light is coming from M1 also, and light is coming from M2 also. Light is coming from M1, light is coming from M2. These are two sources, and the light are coming from two sources. And we know that when the light reaches a point from two sources, this will interfere here, and the interference fringes must be formed. So the interference fringes will be formed at the screen of the telescope, and this interference fringes means dark, bright fringes will be formed at this on the screen of the telescope. Okay. Now what Michelson does is that then it rotates the whole instrument by 90 degrees, so that M2 takes the position of M1 and M1 takes the position of M2. In that case, the fringes will be changed. The position of the fringes will be changed. Again, the fringes will be formed, but in that case, the fringes, the position of the fringes will change, because the path length which is now traveled by the light will be different in that case. So some of the fringes must change. So now we will do the calculation and see what. Suppose the light which is moving in this direction with speed c, and the speed of the ether is v, where v is the speed of the earth, rotation of the earth. So if relative to the earth, the ether is moving with velocity v. So the downstream velocity of the light will be c plus v, and upstream will be c minus v. And in this direction, this will be c square minus v square in both cases. So the time taken, we will calculate the time taken by the light to move from M1, from say its point P, from point P to M1 and back. So time taken by the light signal to travel from P to M1 and back. So In going from P to M1, the time taken will be said T will be equal to, if we take the length L1, so we use the formula S is equal to Vt. If L1 is the length and velocity is C plus V, the time taken will be T, then T will be L1 by C plus V. So the time taken will be L1 by C plus V going from P to M, and return the length is same, but now the speed is C minus V. So the time taken by the light signal to travel from P to M1 and back will be the total time. It's going from P to M1, then M1 to P. And if you say this is called, say, T, or T, okay. You can say simply T or simply T. So if you take the LCM, this will be C square minus V square 2LC. Take the LCM and calculate, you get the same. Because L1, V and L, we will look at V term will cancel out. We will get with 2L1C. You take C square, so it can be written as 2L1 by C. C square is taken out, 1 minus V square by C square. C cancels out, so it is 2L1 by C, 1 minus V square by C square. So this is the time taken by the light pulse to go from P to M1 and back. Say we call it T1. Now calculate the time taken by the light pulse to travel from P to M1, M2 and then back. So I am removing this picture. Now the time taken by the light to travel from P to M2 and back. So it is T2. So it will be where the distance from P to M2 is said L2. So it should be L2 C square minus V square under root plus L2 C square minus V square under root. Because in that case, this was P1, this was nearer L2, this is say L2 distance. Light from going to this way will be have speed C square minus V square under root and the return same velocity. So if you take that, this will be 2 L2 C square minus V square under root takes 2 L2 by C 1 minus V square by C square, or you can write it by 2 L2 by C 1 minus V square by C square. So this was the time taken by the light to travel from P to M1 and this and back. This is the time taken by the light to travel from P to M2 and back. Now take the difference, because that difference the time taken by the light to travel in these two directions. The time difference okay. Now I want to find the time difference. So the time difference to travel from the light to travel in this direction back and in this direction back, because that time difference will produce fringes here on the screen, because the time difference will produce the path length. The path length will produce fringes. So we'll calculate the time difference. Time difference delta t. This minus this will give me the time difference. So it will be 2L1 by C 1 minus V square by C square minus 2L2 by C 1 minus V square by C square. So, from binomial theorem, we know that if a plus b per power is n, this can be written as expanded form like a power n, a power n minus 1, b per power 1, plus n into n minus 1 by factorial 2, a per power n minus 2, b per power 2, plus n into n minus 1, n minus 2, factorial 3, n minus 3, b per power 3, and so on. So this is the binomial theorem we know from mathematics. We use that binomial theorem here. If you take in the numerator, this 1 minus b square by c square, the whole power is minus 1. So if you take that, is 1 minus v square by c square minus 1. The numerator will be minus 1. So instead of n here, it's minus 1. Instead of a, it's 1. So it's 1. Any power on 1 will be 1. Now it's n. So it's n is minus 1 here. There is minus here. So this makes you plus 1. A power n minus 1. This is 1. So it's b is v square by c square. Next, it's minus 1, minus 1, minus 1. That's a minus 2 and minus 1. Minus 1 plus 2 into 1 factorial 2 cancels out. A is 1. So it will be b is v square by c square whole square, and so on. But since v is very much less than c, v square by c square whole power will be is negligibly small. So we neglect the higher powers and we take only the first part, two terms. Similarly here also, this is the power 1 by 2. It's if you take 1 minus v square by c square, it's under root. Under root means 1 by 2. So this will be equal to 1 plus 1 by 2 v square by c square. Neglecting higher orders of V by C. So if you use these formula binomial theorem here, this equation will become L1 by C. This will become 1 plus V square by C square minus, and this 2L2 by C, 1 plus 1 by 2 V square by C square. Now open the bracket. Open the bracket, this will be equal to 2 by C L1 plus L2 or L1 minus L2. Now this one and this one. So plus this will be 2 L1 V square by CQ minus this 2 cancels out. This will be equal to L2 V square by CQ. This is the time difference by the light to travel from this way and this way, from P to M1 and back, P to M2 and back. The difference in time will produce fringe, because the difference of time means the light is approaching from two sources with certain path length, because the time is different, so the path length is different. So that path length will produce fringes here. So this is, suppose you take it says equation 1, 2, 3, whatever like. Now what Michelson has rotated the whole instrument by 90 degrees, so that L2 takes the position, M2 takes the position of M1, M1 takes the position of M2, and again measures the time difference. So in that case, L2 will be L1, L1 will be L2, and this is the whole equation. So now rotate the whole apparatus by 90 degree, so that the mirror M2 takes the position of M1. The mirror M1 takes the position of M2 and measure the time difference again, and now the time difference in this case, and just we will write just like because it will be the same. Okay. So you do not have to calculate those time difference. This will be again this will be this will come first, then come second. L2 will become L1. So it will be L1 by C 1 plus B square by C square. So 2 here minus this will be again 2 by C L1 plus or L1 minus B. If you open the bracket, 2 cancels out, L1 V square by C cube, L1 V square by C cube minus 2 L2 V square by C cube. This is equation 2. Now, in the first case, the time difference is equation 1. In the second case, the time difference is 2. We have just reversed L1 by L2, L2 by L1. So we'll do the same result will comes, because L1 will take the position of L2, L2 will take the position of this sub minus this. Now this time difference in the two cases, if you take the difference of these two time difference, if you take the difference between delta t and delta t dash, it means the path which is travelled by the light in the two cases are different, and that will result in a change in the shift of the interference fringes, because the light which travels by say light comes from here and here. If the light, the effect of the light is say lambda, and the time, if there is a time difference between the two rays approaching this any point say O, there is a time difference, that it means the path, there is a path difference, and the path difference is measured by the speed of light which the light travels. The light travels with say c speed, and the time taken is say delta t. This is the path length which is travelled by the light, and in that time, what's the difference between these two waves? So the difference the two waves, suppose one wave which travel, one wavelength, two wavelength, three wavelength, suppose this has travelled 5 wavelength, this, because the wavelength is the length, this is the wavelength, this is the length. If this one of the length has travelled up to 5 lambda and this next one has travelled up to 3 lambda, the difference is 2 lambda, and that path difference is the time in the light which travels in that time. So if there is a fringe, there is a change in the fringe, it means that fringe shift is due to the path difference. If there is a shift of n fringes and the wavelength of the light is lambda, then this is due to the path travelled by the light. The light travels in this distance. There is a change in the shift of, and this shift is, if n fringes shift, suppose, I have to remove this line, and now suppose in the double slit experiment we assume that the light source is this one and this one, the light which is the screen. So this 1 wavelength, 2 wavelength, 3 wavelength, 3.5 wavelength, 1 wavelength, 2 wavelength, 3 wavelength. Oh no, 1, 2, 3, 1, 2, 3, 3.5. No, it's a take some difference. So difference is that if this is 3.5, suppose it's 1, 2, 3. Oh, 1, 2, 3. So it means if 3 is here, so if they interact, reaches here at in opposite directions, opposite faces, there will be dark here. And if they approaches constructively, there will be a bright fringe. So if there is a path difference in between these two, the fringe will shift. If the fringe here is bright, and if the path difference in between the two rays which arrives here different, then instead of bright, this will be a bright will be here. There is a shift in the fringe. So that is the whole idea here. Because if n is the number of fringe that shifted, and n is the wavelength of the light, this is the distance which is traveled by the light, by the speed of light and the time taken by the light. So if the time difference is measured, if we calculate the time difference in the time, if the time difference is say delta, and delta is difference in between these two times. So the number of fringes that will shift can be written as c times delta t, where delta t is the time difference by lambda. And delta t difference, time difference is this, which we have measured as question 1 and 2. Calculate this difference and see what it comes out to be. So that we are doing here. Oh, so you have to rub these to make space for the next tree. So m is equal to c by lambda delta t minus delta t dash. This is c by 2 L1 minus L2 plus L1 b square by c cube minus L2 b square by c cube minus this minus 2 by c L1 minus L2 plus L1 b square by c cube minus 2 L2 b square by c cube if you for this term and this term will cancel out and you are left with c by lambda L1 by b square by c cube plus it's again it's L1, no it's L2, it must be L1 take. So it's somewhere, somewhere it is, it's here, 2 L1 C1 given here, it's in this case 2 tick. This 2 L1 C1 v square by c cube, this is L1 v square by c cube with minus sign here. So 1 will be L1 v square by c cube plus it is L2 v square by c cube and this is minus plus to 2 L2 v square by 2 and this is L2 v square. So it's 2 minus 1, so it will be L2 v square by so it is c by lambda of v square by c cube L1 plus c cancels out. This is c by lambda V square by C square L1 plus so this is the number of fringes which we have calculated theoretically, which we have calculated. This is that in this experiment this number of fringes must shift if we assume L1 and L2 are the distance of the mirrors from the point source at P1, and if V is the speed of the ether, which is the speed of the earth, C is the speed of light, and lambda is the wavelength that we have used. So everything is we have assumed theoretically, and we have worked out that this number of fringes must shift. So if you write like this, C will cancel, oh no, it means C, oh there is some C, oh it is C cube, sorry, C cube, so this is finished, C cancel out. So it is now if we take L1 is equal to L2 is equal to say L, both the mirrors are the same distance from the source, so it will be 2L, so N will be 2 times L by lambda V square by C square. Now take the values of V, C and lambda and work out what will be the fringe shift. Suppose let L is 10 meter and the wavelength of light which is used is 5000 angstrom and the speed of the earth is 30 kilometer per second and the speed of light is 3 into 10 to the power 5 kilometer per second, and you substitute the values here n, so n will be equal to 2 times V by C, 3 cancel out, so it will be V square, V by C will be 10 to the power minus 4 whole square, because 10 to the power 5, this is 10 to the power 1, so this 30 10 to the power 4 and V by C, so if you take the numerator 30 by V to the power 5 zeros, 1 cube cancels out, so this is 3 cancels out, to 10 to the power minus 4 and square, so it's square, and lambda is 5000 angstrom, can convert into is 5 into 10 to the power minus 7 by 10 meters, meter cancels out. So this is take this is 10 power minus 8, this also 10 to 2, this also cancels out. So this will be 2 by 5, that is 0.4 fringes. So it is less than half fringe. The shift in the fringe is very small, it's not even 1 fringe, it's just less than half, but still it can be measured. Okay. Although the shift in the fringe is very small, but you can measure it. You can measure it by taking the L, if you take L as 100, okay, this will be 4 fringes shift. So that can be measured. But experimentally, these are theoretical calculations. But experimentally, Michelson and Morley found that there is no fringe shifts everywhere. If you do the experiment, you will find no fringe shift. Experimentally, it was found that there is no change in the fringe. what this led to? No fringe shift. Michelson Morley has done this experiment several times, but everywhere it found that there is no change in the shift. This indicates that our idea of ether was wrong, because we have considered this velocity of this was the velocity of the ether. This no fringe shift means there is V0. If V0, then there will be no shift in the fringe. Which means there is no ether which is moving relative to the ether. It means there is nothing which is can be said to be ether. It means there is no medium through which light propagates. So this idea gives a death blow to the idea of this experiment. Gave the death blow to the idea of ether. Now the light travels without any medium. So after this, we will next class we will see Einstein's theory, Einstein's principle. Einstein gave two principles, and the first principle that the earth that every body moves relative to each other. The motion, all motion is relative, and the speed and the laws of nature remain same in all reference frames. It remains same because the space is isotropic. Also, the speed of light is constant in all the medium. The consequences of these two principles we will work out in that gives you Lorentz transformation and so on. So for that will be in the next class. Thank you.